You're watching the 5.9 lesson video on factoring completely day 2. So today in this video, we are going to be doing everything that we did on day 1. We're just going to see some more examples. So nothing is different. We are just going to do some more fun factoring questions. So as a quick memory jog, remember, the first thing that we always check for in factoring completely questions is, yes, you are right, finding the GCF. All right, example number 1. Let's see if we can determine what the GCF is, the greatest common factor. What is the greatest common factor of 3, 3, and negative 18? If you said 3, you are correct. So we're going to pull that out front. But we always need to check for not only the number, but also the variable. So we have an x to the 4th, an x to the 3rd, and an x squared. So the biggest x that we can pull out would be an x squared. All right. So let's now factor out the 3x squared. So 3 divided by 3 is 1. X to the 4th divided by x squared is x squared. If you're not sure how that happened, just think. If we multiply x squared times x squared, we would get x to the 4th because we just add the powers. Okay, so when we are factoring, we just drop it down however many powers. In this case, we're dropping it down by 2 because it's x squared. All right, 3 divided by 3 is 1, so we're dealing with another positive 1 here. And then x cubed divided by x squared is just plain old x. Okay, and then negative 18 divided by 3 is negative 6. And then x squared divided by x squared, well, that's just 1, so we're not going to write it. All right, so we factored out the GCF. Now we have this trinomial that's kind of sitting nice and pretty inside our parentheses, which means that we should probably use a box method to factor him. So I'm going to show that off to the side. We need to factor x squared plus 1x minus 6. Okay, so x times x is x squared. You know the drill. We need two numbers that multiply to a negative 6, so that means that one of the numbers has to be positive and the other has to be negative. But then they have to add to a positive number, so the bigger number has to be positive. So 6 and 1 multiply to 6, so to 3 and 2. I'm going to go with 3 and 2. Oops. And then I have a 2x here and a 3x there. We talked about one of them being positive and the other one negative. So the only way right now, because 2x plus 3x is 5x, that's not what I want. I need to make the 2 negative, because 3x and negative 2x is the 1x that we wanted. So this is our positive. So our last and final step is just to write each of our sides as 2 factors. So whatever I have highlighted in yellow, this is identical to that. This is where it came from. So here's my final answer. I'm just going to box it in. And if I wanted to make sure that I was right, I would graph my original here and my new, and that would show me that I am correct. All right, example number 2 is down here. So this one looks a little interesting. All right, first things first, check for the GCF. Do 45 and 5 have a common factor? The answer is yes, they do. So I'm going to factor out a 5. 45 divided by 5 is 9. So this becomes 9 minus x squared. All right, well, that looks a little weird, but I still think that we can do this. I think we can factor it. So I'm going to put this down below. Now, usually we put our constant in this bottom box here, but we always put our first term here. So I'm going to kind of do something a little bit different, and I'm going to put the 9 there and the minus x squared in this bottom corner here. Okay, I don't have any x terms, so we're just going to show that that's 0. And let's do some factoring. What times what is 9? Well, 9 times 1 and 3 times 3. I'm going to use 3 times 3 because it looks like we have the difference of 2 squares happening here. All right, x times x is x squared, but I need for one of them to be negative in order to produce that negative x squared. And why do I like this so much right now? Because if I multiply x times 3 and negative x times 3, if I add these two guys together, I get 0. So we factor this correctly. All right, so the 5 comes down along for the ride, and my two new factors are 3 plus x, that's this right here, and then 3 minus x. And we know that we're finished because I don't have any x squareds in my parentheses. All right, moving up to example number 3, a to the 4th minus 1. All right, check for the GCF. They both have 1 in common, but factoring out a GCF of 1 is pointless. Do they both have a's in common? No. All right, so I guess we just need to use the box to help us factor. All right. Well, it looks like we have the difference of 2 squares. Some of you might not even need the box at this point, but let's just show it. How do I get a to the 4th? Well, if you're thinking a squared times a squared, you're correct. How do I get negative 1, but also get my terms to cancel out to be 0? If you said positive 1 and negative 1, you're correct, because that becomes a squared minus a squared, equaling 0. So my two factors, remember, are on the sides of my boxes. So this factors to become a squared plus 1 and a squared minus 1. Now remember, it's called the difference of 2 squares for a reason, because we're subtracting. So anytime I have 2 squares that are being subtracted, we can factor it. But if there's addition, that's bad news for us. That will not factor. So right away, I know that my a squared plus 1 is going to come down for the ride. But my a squared minus 1 is going to factor. Now, I'm not going to show the box here because I think we've gotten the hang of these difference of perfect squares by now. So again, we are just factoring this term here into these two new factors. So what times what is a squared? A times a. And what times what is 1? 1 times 1 has to be the same number every time, remember. And then one of them is a positive and one of them is a minus. So now we've factored this completely because this a squared minus 1, a squared plus 1 factor at the beginning can't be factored anymore. All right, we haven't done any checking, so let's hop to our calculator. Go ahead and pause the video if you need to. We're going to create a new document, and I am going to check my answer here. Now remember, our calculator does not understand a's, so we are just going to code it as x to the 4th, minus, I got to get that minus out of the exponent, minus 1. And then I'm going to hit enter. So this is my a to the 4th minus 1. Kind of looks weird. Kind of looks like a parabola. It's kind of weird at the bottom. All right, hit tab. And then we are going to graph x squared plus 1. Notice how I have to use x's. X plus 1 all times x minus 1. So all of my a's became x's. You hit enter. We did this correctly because they lined up. All right, last example. Example number 4, x to the 4th minus 18x squared plus 81. What are we checking for? GCF. Is there a GCF? No, there's not. I don't have x's in common, and my GCF of an actual number is 1. All right, so box it up. I'm going to do that in the bottom corner down here, or actually, I'll show it in this space here. I have some space. X to the 4th. My tail is minus 18x squared, and then a positive 81. All right. Well, x squared times x squared is x to the 4th, because we just add the powers when we multiply. All right, now I need two numbers that multiply to 81, but add to negative 18. So I could try 1 and 81. I don't think that's going to add to negative 18 anyway. I could try like 3 and another number, but also I think that that's not going to work out to my benefit. But I do know that 81 is a perfect square, so I think I'm going to try 9 and 9. 9 times 9. Well, 9 times 9 is positive 81. Wait a minute. 9x squared plus 9x squared is 18x squared. I needed a negative 18x squared, so let's just make them both negative, and then it works out. Oh, glorious day. All right, so x squared minus 9 all times x squared minus 9. And would you look at this? We have the difference of two perfect squares doubled. Okay, so this guy right here can be factored into two factors because it's a difference of perfect squares. So x times x is x squared. 3 times 3 is 9, but one of them has to be positive and the other one has to be negative in order to make that minus 9, and then also add to 0 in the middle. And guess what? If x squared minus 9 is that factored, we're just going to copy and paste what we just did. Why double the work? So x plus 3 all times x minus 3. Now, we could get fancy and write them a little differently. Like if you wanted to, you could write this as x plus 3 all squared times x minus 3 all squared, but you do not have to do that. All right, I do want to rewind this, I think, right here, because I wanted to show you one thing that your calculator is going to yell at you about. So hit Control, add a page, and we're going to add a graph. And I just want to graph this bottom part here. So let's suppose we're checking, and we're just going to type it in as 3x squared parentheses x minus 2. Do this with me, x plus 3. So we're just going to graph our answer. Okay, and the reason why, what did I do here? There we go. Okay, and then if you hit enter, oh, my calculator fixed this. I don't know if it usually does. All right, so some calculators might give you an error message. So if that is the case, what you want to always do is add in a multiplication dot after the 3x squared. Sometimes because there's a variable out in front, calculators get a little cranky. I think it depends on the operating system that you're in. So they might have fixed it since then. I don't know if it's just on the CX2 models. Some of you are using the CX1 models, and it might have given you an error message. I have a feeling it's going to. So make sure that you make this appear on your calculator. Don't just watch me do it because you're like, nothing happened, and you're right. But it could have. So if you ever get an error, just go back, hit tab to make this appear, and add in that little multiplication dot right there.